那个博士班的学生都来了吗？博士举手一下。啊，1、2，啊，只有2个。Where is 英方 and the 英方over there。还有了，应该不要只有这几个吧？廖开言。啊 ，OK， 来了，我们还有一位在加纳，他等一下会连线上来。加纳年啊，他已经终于得到了那个 visa， 对，好不容易。去年那个跑到大陆去了，那今年这个终于可以来台湾了。OK， 我们有一个非洲生了。啊？这就是我们来讨论问题吗？他杀人放火，我要去替他被关吗？我来先让他签一个自我了断合约。OK， 再把它放过来这边啊，这边有一个人杀的。好，在这之前哈，我们今天我们是林芳邦博士的演讲哈。那等一下你们可以看到林芳邦林博士他是林教授哈，他的专长在Big Data 数据哈，他的任职单位叫做国家网路中心哈。如果你们现在手上有资料，可以上去查一下。国家网路中心是属于科技部，那现在叫国科会了哈，以前又改回来叫国科会。国科会里面有一个国家实验室，国家实验室里面有好多的实验室，有发射卫星的，有地震中心，有很多中心，其中一个叫做网路中心啊。那它是这里面的高速运算中心，是不是？OK， NCHC 哈。然后他今天要跟我们讲的是有关大数据 Big Data 的这个议题哈。那在这之前哈，我想我要讲一个很励志的故事你们看到我其实已经认识很久，从我在能源中心担任副主任的时候就跟芳邦认识，每年我们都有举办一些会议。今天这个林老师来这边哈，他是掌管的是我们你可以想象说，台湾有一个很大，你们手上都有计算机。这个国家级的计算机就在他手上，当你们城市跑不动了，他手上那个超级电脑可以跑得动。那这个是一个平台，这个平台会让我们的这个都市计划也是一个跨领域的东西。你不管你是做交通的、做经济的、做地震的、做景观的、做任何东西，只要有模拟运算，你们的那个设备动不了，找他。所以他那边今天中午跟几个老师聊过了哈。有一些合作的议题可以慢慢再讨论。我们希望能够建立跟国家级的这种运算中心的合作关系，特别是你是论文里面需要用到非常大数量的尤其博士生那以后能够都跟这种国家级的网络中心合作那我刚刚讲励志的这个故事不是这个东西，这个是前言你们看到这个海报上这里没有海报。你们看到海报上的林芳邦林教授跟现在这个型男完全是不一样。你们知道他以前有多胖吗？我喜欢消遣他，因为他以前那个身材坐到我的车子里面去，然后在前座，我那个车子前座算蛮宽，他坐进去之后，因为他那个身材不小心他那个脚把我那个一个按锁转了一下，把我的 gear 锁住了。那我不知道，我这边转了半天打不进去，因为车子坏掉了。我要让他自己一个人走到车站去这张把它放你知道这是2014年我们在 Gainesville 的时候拍的照片，那个时候他这样，他体重大概是我的2倍那后来他是立志要减肥减成像这样这个样子所以他是一个非常励志，所以那个体重减肥不是问题，看你有没有决心而已OK， 这个然后这个是眼镜是那个大会提供的 就是会场，就是我们在那边做。其实参加这种会议最大的好处就是可以认识很多不同领域的。当然我们自己同领域的要去知道这个不同的这个研究方法怎么应用在我们的这个专业上面。但是你去到这种国家的其实网络中心它里面它有一个 central 是跨很多里面的，这都是做高速运算的。那有一些是做生物辨识，有些等一下他会介绍。你可以认识很多不同领域的，但是你会发现有一些方法毕竟是可以相互连通的。那我们在这边去做了参访，那时候它是长这个样子，所以后来因为把我车子也不算弄坏，把它锁起来，后来我才知道说原来是他把我锁起来了，让我车子开不动。好，那2-3年没有见面现在变这样型男，我差点认不出来所以我们欢迎一下林芳邦林教授。Okay. Also, I have one more note because we have students from Ghana. He is from Africa, and now he is in the morning 6:15 in the morning. So I think he's online, and I think it's better to be bilingual. It's your choice. Okay, thank you. 我们欢迎一下林芳邦林老师。
我可以跟大家share 2段，这是第1段啊。No, I'm kidding. Okay. 我刚刚那个样子已经20几年了。那我是刚好在 COVID 前的时候，就是突然间心脏觉得不适了，就是心跳不规律，所以想说，my time has come. So yeah, that's the only chance that you really really commit. I mean to do a kind of health management 所以我开始每天走路走，然后固定时间去睡觉，绝不熬夜。然后每天都吃得很规律这样子然后大概半年就是现在这个样子所以如果说同学这个有跟我类似的问题就是可以这样做不是心脏问题啦，就是你 health 上面的，或是你觉得你要更 fit 一点这个都是一个 opportunity 没有做168，我觉得非常非常正常的3餐然后不要吃冰淇淋，不要吃那种不是不吃啦，就是少吃啦。Okay, anyway, so let's back to our topic. The one that I'd like to share is AI, big data, and their applications. When Professor Chen asked me to give a talk here, I really think what kind of things that I can deliver. Okay, our center, National Center for High Performance Computer, actually is high performance computing. Actually, is a supercomputing center. We served infrastructure, okay? But we collaborate with application domain experts. So I explained a little bit detail. I didn't put those kind of things, which is introduction of my organizations in the slide set. But I'd like to give a very brief introduction of it. We were founded in 1991. And we grow in around year 2000. The reason actually we grew from one single building in Hsinchu, which is located in Science Park, Hsinchu Science Park, extended to Taichung and Tainan. Now in Taichung Science Park we have a branch, and also there's another branch in southern part, which is in Tainan Science Park. And those kind of 3 buildings are connected by backbone network, very fat, thick network. And the reason is because in 1999 we have a very big earthquake, right? Remember? 921大地震然后那个中心新村 is completely annihilated, right? It's completely collapsed. So we propose that data can escape, which is now related to what we are going to talk about in this lecture. Right. So you know my background, and now our center actually has 2 parts. One is a computing facility. The other is network, national network. So if you are researchers, which is now you are mostly, I think all of you are postgrad students, right? If you want to access international resources through internet, you will go through our center 100% for sure. Because we are kind of planned, build and operate Taiwan's research and educational network, which means named the TWAREN, okay? So this is the one that we operate. So there's a lot of some applications that related, in particular in cybersecurity, related to the infrastructure that we are operating and served at the moment. But I will be focusing on I'm trying to organize the talk in kind of more focusing on the data, right? So that might be easier. I was told that I have 60 minutes, so I will make it as short as possible, right? And perhaps another 60 minutes we do Q&A, and I can present more. Okay, so this is the slides that I'd like to present as the first slides in the past almost 20 years. And when it was published in 2001, and actually our center is very focusing on supercomputers. But we found actually in 2000, the rising of the optical fiber is kind of central at the central positions. So there's a publication called Triumph of Lights published in Scientific America. And you can see here, this is the prediction is what's happened now. Even 20 years, this kind of prediction is still valid. So if you look at here, actually this is kind of things, the core technologies for ICT in general, you can look into 3 parts. One is Moore's law, which means the density of the devices within 就是晶片的大小哈，就是 per square inch 晶片的大小。It's actually follow Moore's law. Moore is the founder of Intel company, okay? And he predicted that the chips will kind of double every 18 months, 1.5 year. And another prediction is about storage. The density of the storage 就是那个磁碟密度啊，磁片的那个密度。It will kind of double every 12 months. If you look at the optical fiber, it is also called Gilder's law. And actually, it doubles every 9 months. So you can see it's exponential growth. So you will see what's happening now is not only how fast you can compute. It's also something to do with what you can do when they are connected together. And you have to prepare for that, okay? And that's the reason our center is not only responsible for supercomputers, and you also have to think about the networking, how they connected, what kind of, after the connectivity, after the connection, what can you do for that, okay? Of course, ultimately you will serve applications, and which is, I think this department is more, for our perspective, is more of the application parts. So this is, I think, this is a very crucial slides, laid out all the foundation, all the development of what we are going to talk about. So if you talk about big data or AI, here this one I'm, actually I gave another talk in 2019, almost 20 years, but still valid. So you can see here, there's an accelerator. Actually, it is not the we call it 就是复杂指令集了哈。那现在还有一个简单指令集，然后整个的 chips 的那个密度越来越高。等一下我会I will explain more details about Moore's law. So here we actually Moore's law is at the end of the Moore's predictions. So we now more towards accelerator, which is GPU. It's a different architecture from the CPU stuff, and so only when we can use kind of a different technology, a different architecture, we can say kind of bypass Moore's law. So there's a 2-track of the architecture they are developing. One is accelerator, and accelerator including quantum computing, quantum computers. So the emerging technology about the quantum computing, they also think it's really, well, although people are talking about thousands of qubits, and you can do a quantum computers, say, as a supercomputers. That's one track. But we found actually quantum computer has to work with a classic computer. So the architecture should be side by side. So there's no, one of the key perspective for quantum computer is now regarded as an accelerator as well. So I put it together. So if you look at the storage, now you are, it is more affordable for store more and more data. So now you can store raw data, right? In the past, it's really, really challenging. When I studied in UK back in 1991 to 95, okay, I'm very old now. 91, yeah, still. I remember I bought the 300 megabyte storage hard drive. It's extremely expensive. It is, I think it's around more than approximately 20,000 NT dollars. It's very expensive. 300 megabyte 的这个硬碟，我花了将近2万块啊。那个 anyway, but it's really make a lot of differences. And also, if you look at the optical fibers, the growth of the optical fiber now also extended to communication network, right? So you have 5G, 6G in the future, and now you even talk about Starlink's satellite connectivities. It's a telecom kind of telecommunications. It's very different from fixed network that I'm talking about, which is based on optical fibers. But both of them now are converged. It's all to do with the connectivity. Okay, so here, without any kind of incidents, you know that you will definitely go towards some kind of a cloud. This is a kind of cloud services, which is actually you are leveraging all this kind of development. And all of them, if you combine them together, it is now the AI what we are talking about. Okay, artificial intelligence, that's the next movement for sure. And I believe the next 10 years will be the edge of AI. And I'll explain more details. Even some scientists from physics, okay, from fundamental science, and they are quite resistant to it because they are doing simulation hypothesis-based, which means you have to solve partial differential equations, right? But now it's not necessary to solve it. It's really, really toward that directions. Although, of course, we are still heavily reliant on partial differential equation, PDE. 所以你基本上解一个偏微分方程啊 ，using C++ or C. I'm the C writer, so I'm dinosaur level. Right. So this is what's talk about the Moore's law. If you look, actually Moore's law can look back 120 years, and starting from resist 就是那个电晶体啊，哈，电晶体。Okay. So you can see this is yeah, right. One is a mechanical. The old day in the old days, for instance, in World War I, if you look at the simulation game, and there's a film called Simulation Game. Have you watched that? 就是模仿游戏，大家有没有看过那个电影啊？啊，就是在一次大战嘛，对不对？一次大战的时候，二次大战，电脑发展的非常非常快。所以二次大战的时候，就是要破解那个德军的密码，啊，它事实上就是用 mechanical 的解码器，啊 ，and that's the birth of the supercomputer， OK。然后呢，接下来就是有这个真空管 vacuum， 再来 transistor， 然后现在是那个 integrated circuit， 啊，所以这个部分你可以看它的生长。可是 if you look at the trend, it's almost linear, right? It's growth. So this is a prediction of Moore's law. And he predicted that every year, every 18 months, not every year, every 18 months there were doubles. And 所以你可以想成一个复利的观念，对不对？所以它就是 exponential growth. And if you look at that, is there any, what's next? Is there the end? Is there the end of the Moore's law? The answer is yes. And if you look at the silicon's atoms, it's 0.2 nanometers. So what's the process, manufacturing process in TSMC? 在台积电，你知道现在最小的那个 processing, 1 nanometers, right? 1 nanometer. So around 5 silicon atoms with 差不多那个宽度，5个细原子的宽度。That's the limit of human being for sure. I don't know how much they can push the envelope. Okay? 所以你看到这边哈，细晶体0.2。 So if you look at this is actually old information that I collected, but it's much, if you look at the 7 nanometers process, it's around 35 silicon atoms width, okay? So people are talking about what's the limit. So this is actually another reason why people are talking about quantum computing, because there really has a limitations for traditional classic computer if you look at the very fundamental parts in physics, okay? So the progress of quantum computing is they actually has an algorithm already developed and proved they can solve the RSA. RSA 就是一个密码了啊，大家知道有没有同学知道 RSA 是什么呢？啊，它是3个名字啊，3个数学家的名字哈。他们现在呢，你包括银行转账啊什么都是背上 RSA。啊，最基本的了啊，当然现在有什么 elliptic 啊什么的这些encryption 的 methods， 不过基本上来讲，在用传统电脑 ，it is the classic computer still can solve RSA encoding, decoding, encryptions, but it will spend 1,000 years to solve it. Okay, so it doesn't matter because I use it and just for minutes or hours. Or days, so it doesn't matter whether you can decrypt it or not. But now the new algorithms, for instance, Shor's algorithm, this is a very famous one. It can solve actually using quantum computer. Actually, can solve can decrypt RSA code within seconds. 在1秒之内就可以解开 RSA. So there's no security at all. That's why the financial sector is the #1 industry that really like to investigate on quantum computer. Okay. So this is another thing that what's the trend? What's the next for Moore's law? So let's go back here. So this one. So this will be another trend for that. Okay. And the interesting thing is people are talking about if quantum computer can. What's the #1 problem that we should tackle in if we're using quantum computer? It's actually related to a classic computer as well. And people are thinking it will be AI, okay? Which is solving the linear equations, you know, AX equal Y, okay? X, Y are observation data. And you are trying to tackle whether we can solve this kind of linear equation or not. This kind of linear equation is linearized equation. Either you linearize from partial differential equations or linearize from, say, neural network. Okay, so there's a different kind of linearization that you can undertake if you want to solve, and so there's an algorithm developed already for quantum computer as well. So this is all the trend that when we look at it, and you have to be very aware, although you are possibly from say the urban planning, but if you look at what's happening now, there's almost everything is cross-discipline. Okay, so we call it a transformative computing. So the computation is no longer kind of classified as, okay, this is urban planning computing. Okay, this is computer science computing. This is a kind of a graphic computing. No, there's no such things actually. Everything now interconnected. Even sociologies, I think I have some slides said, I don't know whether I have time to talk about it. It's about large language models. But anyway, I skip it. If you are interested, I can talk a little bit more. So this is a little bit of Taiwan supercomputer, which our center operate. And so these are the old slides. But the key thing is how the computing power grows. Okay, this is how it grows. So now we hope in 2025, we actually are getting funding at the moment, getting budget at the moment. It's approved by Ministry of Science and Technology Councils, but not approved by 立法院 yet. So we make an effort. We hope to push to 300 petaflops machines, okay? And the flops means this is a, let me see. This is a flops, okay? Means floating point operation per second, okay? Peta means 10 power 15, 10的15次方 ，OK。然后 floating point 就是每秒钟我用时数去做运算的时候，它会花的这个，我可以做多少时数运算，所以每秒钟我可以做15次方的时数运算，啊，它的意思是这样啊，所以大家用这个基准来做比较。 所以事实上它成长得非常快。那我们现在是9 petaflops， 对不对？那事实上现在最快的 machine 呢，已经可以到将近1个 exa 10的18次方。We are much behind. It's a kind of almost like a arm competition 军火的竞赛所以这个我们也是很紧张，就是说不是只有你们看到的晶片竞赛而已。事实上，在整个的这种所谓的超级电脑，所谓电脑上的组合整合然后另外一个就是跟你们现在 big data 的关系，不是只有 compute， 它从 edge 端，从 sensor 端一直到这个 compute、supercomputer、data analysis、artificial intelligence， 事实上现在都 converge together。Actually， 现在最快的 machine 最快的 machine 号称是可以到 exascale 将近1个 exascale， 还没有到 exascale 了。那基本上来讲，去年的话，事实上是 around 600 to 700 as far as I remember, around 600. They call it quasi-exascale computers. But if you are talking about 64, this is more jargon in our field. If you are running a 64-bit machines, 64位元就是说你们一般做实数运算的话是64位元。64 machines actually it is around 600 petaflops. But if you run 32, it's more than 1 exa. So most of artificial intelligence doesn't need they don't need 64 bits precision. They only need 32 or even 16. So there's exa computing there already for artificial intelligence. Okay. So I think everyone has to be alerted. All right, this is some of my research before. I'd like to share with you. Back in around 2002, I'm more a computer scientist. I'm doing computational fluid dynamics. I'm solving partial differential Navier-Stokes equations, if you heard of it. But in 2002, I decided to do something and stretch my research. So I work on sensor and sensor network. And so collaborate with ecologists and neurologists. 就是那个生态学跟湖泊学And so the reason that I do it is I'm not really say I want to focus on some specific field. What I want to do is actually sensors will dominate the data generation. You generate a lot of data. So at that time, I have a vision that in the future, if you connect it to everyone, just like mobile phone that you have now, you will keep collecting information back, right? And it's a kind of a multiply by numbers for sure, okay? And very easy to understand it nowadays. But if you back 20 years back, it's very challenging to understand it. So I was challenged within our center actually at that time when I do these kind of things. And then 2002, 2003, what's happening? Do you know that? Still remember? SARS outbreak, right? Now the COVID actually is SARS-2, version 2. 它们是一样的病毒。都是那种冠状病毒，事实上那个SARS-1 跟 SARS-2 2003年跟现在这个几乎是好像是 doomed 的而且他们是那时候其实大家把它称为 SARS-2 在事实上在那个他们传染病学里面的那个 community. But anyway, so at the time this outbreak, so we developed SARS grid, okay, grid technology. So we try to develop something for application as well, and so that a supercomputer can analyze the information collected from sensors when you're observing the people that are infected, okay, or in the hospital. Taiwan's case is very specific. Taiwan's case is a depletion of medical resources, okay, because the SARS-1 is occurred in the hospital. 这和平医院被封起来嘛so they contain, they use the middle age kind of a paradigm 就是用中世纪的这种思考就是一个村落有黑死病全部围起来不准你出来这个就是和平医院发生的状况 But also that's what can help, it's connectivity can help. So at that time, actually, it's the first few examples that we were able to help them through the network connectivities. And we send the information, and when the medical doctor within the hospital, they have a kind of long scanned imagings, they can send it out through the network. And so using our dedicated network, so also share with the Ministry of Health as well, 就是跟那时候的卫福部还有 CDC Center of Disease Control, and we share those kind of data. So our focusing is on connectivity. So if you look at the graph here, this is a connectivity dominate, right? So that's the philosophy behind that. We actually thinking that we have to leverage in the connectivity, and things should connect it together. So we are thinking that special vehicles, for instance, satellites. Okay, there's a sensor in satellites. Okay. And how about the research ship, 研究船, aircrafts, okay, and meteorological stations, etc. Everywhere they have sensors, okay, in the manufacturing plants, okay, 在工厂里面也有. So its growth actually larger and broader. So now we call it IoT, Internet of Things, already. So it's a completely different growth. But at the time, from our perspective, they were definitely doomed to arrive this kind of development for sure. And then you see the social network, right? You have Facebook, you have a lot of things, and that connected people together in the virtual world. So those kind of infrastructure now, United States in National Science Foundation, they gave it a new name called cyber infrastructure. Cyber means network. Infrastructure means everything related to network. So that's the cyber infrastructures. So all the supercomputer center now turn into a cyber infrastructure centers. So this is a game changer connectivity, but I realize that actually that's not the end road for what's as a system developer, as people that really watching on system, watching on hardware. Actually, it is not the connectivity only. The ultimate things, I collaborate a lot with the scientists, and I found the really game changer is not just the connectivity. This is just the tools. Actually, data is a real game changer. I think this is more than you have a very large data or you have a very diverse data that you want to leveraging it. But ultimately, data will be the key of it. So let's go back a little bit here. Okay, so here you are now able in a very economical way to save all the raw data, for sure. So very inexpensively save your data for a longer time, okay? But what we found, this may be straightforward, but what we found interesting is there's a lot of things. Usually modeling is from hypothesis to discovery, right? And when the Newton, 事实上牛顿是通过 observation， 然后通过 hypothesis， 通过假设，然后来建他的 model。因为为什么？他没有什么 tool， 他只有铅笔跟纸，他没有像我们这样，所以他把资料记录下来，然后用一个 hypothesis 做假设，所以他就可以 fit 到所有的 condition， 对不对？那我们现在有很多的资料，它后面是不是隐藏一个 pattern？So we are thinking in a reverse way. Okay, the reason why Newton couldn't do what we do now, is because Newton doesn't have a supercomputer, doesn't have very large storage. Okay, so that's why the statistics are sort of the equilibrium equations developed, and based on hypothesis. But now we are more on discovery side, and the data, the multiple different kind of data now. We are not looking, say, okay, the physical world is a perfect world. Now we are looking on what's the relationship between data. For instance, human behaviors and some kind of traffics, whether there's a relationship. Can you derive a rule of it? Is there any hypothesis behind? It's not unthinkable in the future, in the past, right? You have to make a very special hypothesis, and it's a kind of it's not really very, very much empirical, 就是非常经验性的东西. Okay, so So now the phenomenon behavior is what really data is concerned about. So it's all to do with the understanding. Can we understand better? And this is a project that I undertook before, back in 2009 and 4 years, and 2013. And if you look at here, called Fish for Knowledge, I put a lot of sensor around the eco sites. And this is one of the collaboration that I did. I collaborate with Europe, and we apply the European projects. And I put the sensor camera, actually, and also temperature thermistic change within the waters. What we would like to do is we actually observing the fish and the coral reef. We 在南湾呐，这是那个核电厂。The money is from nuclear power plant, and we are not advocate for nuclear energies, but they like us to help them. I mean, not really cosmetic. Cosmetic. 我们不是要做美容啦，帮他们美化。And we try to help them, I mean, to see what's the impact of the environment from the perspective of nuclear power plant. And they have a temperature pollutions, contaminations. And so we are helping them to see how the environment evolved. So we put the camera there as well. And it's a kind of 24/7 observations. So we keep, we are supercomputing center, remember, and we have a lot of, now the storage is not expensive. So we store all the imaging data, okay? And also we do the live streaming, and so you can see either from Europe or from US or from our center, you can observe. And we put a lot of camera actually around in the eco environment. One example is in 福山植物园所以我跟我小孩那时候大概5、6点会爬起来看福山植物园的发生什么事情那个野猪在那边拱然后猴子在那边玩This is very, very interesting. Also very educational. And this is another thing that we did. We actually put underwaters in near nuclear power plant. And because of collecting so many data, so we try to use the data. This is a kind of the data that we collected is every year it's 112 terabytes. Okay, 10的12次方然后and then what we like to do is we actually try to derive the descriptive data around 20 terabytes. And the fish that we detected or extracted is around 10 power 10. 所以大概11只的这个鱼So summary data, what's happening, what's the situation? We summarized 500 gigabytes of data. So we like to do the real-time queries. What's happening now in Kenting? And what's the fish abundance, the species abundance now in Kenting? And so we like to have a 1-second query answering. You have to answer. Remember, this is a pre-deep learning age. So back in around 2009, okay, 2010, 2010年2010年2009年的时候 And this is it's a very heavy loading. So we're using our supercomputer, well, not really supercomputer, but a computer that we try to streaming the data in, and there's a lot of technologies to reduce the resolution and increase the quality of the modeling, and do the parallelism as well, and so that we can see in real time what's happening on the coral reef area in Kenting. And in Europe, and they try to analyze and using ontologies and all sorts of graphic technologies, graphic processing technologies. Okay. Yeah. And so you have to develop new technologies. Can you do it in a low resolution? So that's another technology that usually in the HPC center that we have to do. So which means how to enhance remain the accuracy, but raise or enhance the performance as well, or efficiency of your computation. Okay. Right, so skip it. So this is an old technology that we do. It's old already, back in 2010. Okay, so now we're focusing on data already, right? So the interesting thing in this work, what we found is data is not as straightforward as we thought. The number one is data quality. So this is the data we collected, environment data. So sometimes the system problems, the network problem. Sometimes the algae grows around your camera. And sometimes it's blurring and highly blurring because of the typhoon or something, and then there's a mud on the seabed, and they will disturb and kind of smear the water. Another one is sometimes we move the camera and it's so complicated. Can you see the fish here? You want to detect the fish? Can you do a detection for this one? Okay, so we call the complex scenes. So there's only 30% of the data that we can use. So this is a really key issues for big data. How to ensure your data quality. And this is just one of the examples. And this example is a genuine that we encountered in the past. And this is another project that I undertake. Actually, we grow a global network for lake, freshwater lake, 就淡水湖啊. And we were able to connect 25,000 lakes across the world. Okay, so you can see here, this is the distribution of the work. And we try to see the patterns. And at the time, we call it high frequency analysis, 高频的这个分析啊. Okay. Right, so this is another work that we do, and we try to do it. Okay, this is kind of a conclusion, kind of a data features that we never really aware. So this is the things that I'd like you to really aware what's the data that around us. The key issue that you will face, not just the data loss. For instance, if you are doing observations, and if typhoon came, you lost almost 1 week to 2 weeks data, for sure. Can you build a model? If you lost from time to time, either human errors, natural disaster, all sort of things, okay? Or your student, your postgrad student pressed the wrong key, and it should be delete. It should be the save and press delete. Okay, that's another story that it's occurred to me when I moved from UK to. I studied in actually I did my postdoc in Oxford Computing Lab with the Rolls-Royce company, the project from Rolls-Royce company. No, I have a big guy bring back to Taiwan, and NCSC operator just inserting and press delete. I was so young. I say, okay, I don't care. I can rebuild it, but it's not truth. I can rebuild in the code, but I cannot rebuild the data. Data lost. It's lost forever. Okay. So I like to draw your attention here. So natural disaster, facility infrastructure failure, storage failure, all sorts of failure. Format obsolete. This is the key things. Okay. In the past, you have 5.2 disk drive, right? And then 3.5 disk drive. 3寸半的那个磁碟片嘛，然后再来就是像 USB 嘛，你现在3寸半可以找得到 driver 吗？我小孩小的时候，我们在英国是用的 VHS， 结果现在找不到 VSS 的这个 driver，it's really really bad， 都没有。Okay, remember, time really flies. Okay, so this is actually I think this is also very critical figures about the data. If you don't manage data, don't manage you as well. Don't ignore you as well. So if you look at here, and this is published by ecologists, Maschner, but it can be generalized to use for every field. So this is information entropy, meaning the richness of information within your data, okay? So it's a general, very abstractions, but it means the data as it is. You have the data now. So this is time for publications, which means you generate the data, you have the data, you understand the data. Usually in academia, it means you're a PhD student. And when they graduate, what's happening when they published? No one knows what's happening in some sense. You are lost information. Even you in the same lab, you are actually the guys who are kind of your academic brother, you know the work in the same lab, but sometimes you have to ring him or her, right? So what's happening in your code? What's the meaning of the data here and there, right? And that's what's usually occur. So here, you will definitely lose some specific details for sure, 100%. If you don't do any data management, what's happening? You will gradually, the data will die. And maybe some accident right? Some accident, just like my case, okay? Actually bring Rolls-Royce aircraft back and it was deleted. and retirement of the or career change, okay? Okay, for instance, a graduate student and they graduate. For us, we have some colleagues, they moved the job to other company as well. Or some professor retires, everything is in his drawer. When you open the drawer, you couldn't understand what's inside, right? And that's what's happening, even whether it's digitized or physical ones, okay? And until the data completely dead. The death of data is not the data disappear. The death of the data is no one understand what the data is. There's no any annotations, no any explanations. So this is the graph that I really, really like a lot. This is my personal experiences as well. Okay. 我还有一个经验，我再用中文讲，就是我有一个同事，他就是我们在福山植物园录制了5年的资料，啊，包括气象资料这个相关的，还有包括影像资料。结果他要，因为他们是做系统的，他要把这些资料说转给另外一个人，然后把这个资料 delete 掉。就2个谈着就把它 delete 掉，所以就把5年的资料全部 delete 掉。5年的 no copy， because we are not data guys, we are system guys. When project finished, when the result published, we are done. You know? 所以呢，业务单位也是一样，公务单位业务一样。When they finish, they collect the data. It's done. Okay, and you say no. That's the starting point of my research, but there's no business to do with them for sure. Okay, 所以这张呢 ，so the conclusion is data has life cycle. Okay, 资料是有生命周期的。Please do bear in mind, data really has life cycle. It is not dry things lying on your disk or take the note under your papers or your notebook. They have a life cycles. Okay, so this is a big data ecosystems. So you have data generated, the one that I just said, either from people's or from internet. Everywhere you can generate data. Okay, once it's generated and you are processing it. So in terms of big data, if data is huge, there's a lot of technology developed for it for the past 15 years already. And also information processing, you want understanding the data in more details. And people now are more aware that high frequency data, because in the past we don't have a faster machine to process it. Now you have. So you can really do the real-time processing. And then, better than that, you have mobile phone, all sorts of devices. You actually can share the data or kind of a deep knowledge or collect the information or share the information. Or ultimately share the knowledge, share your understanding. And then maybe you can do some predictions in the future. And ultimately do the decision, okay? In particular for policymakers. So, okay, I think I mentioned this one. This is another example in COVID. This is about connectivity. Zoom stock price rise 1,000%, okay? I'm the Zoom user before. 你知道 Zoom 吗？大家知道吗？后来说他的那个老板是中国人。所以我们政府单位全部禁掉，后来他们的 service 也非常烂，所以我也把它放掉。Okay, so I think I skip this one. This just means digitization is crucial. Okay, skip this one. Right, so this is a kind of symbolic, very simple figure. You can see there's a different colors actually collected from different, within the department, within the organization. You can say within a country as well. Actually, the data means a different feature of data. So after organizing, and this is what's happening in big data, and then you have more structured data. But now we are more concerned about AI-ready data, which is critical now. 因为很多的资料，即使你整理完了，并不是给 AI 分析的，所以要有一个 AI 分析准备好的资料。那现在是最新的发展how to prepare for that. Okay, skip this one. This is a different industry. If you invest, you are on the right track. If not, you have trouble in the future. Right. So, oh, sorry. This is a PDF. So, 这个是那个 YouTube 的，我看我可不可以连上去，好像不行啊。就是我看看。 这个是，就是说你现在的 simulation， 这个是 traditional 的 ，two-phase flows， but this is completely using AI. Yeah, simulation on YouTube. Sorry. Yeah, but let me see. 对，这是动画，没关系，我等一下再给你们看好了。这个都是动画，这个是设计的哈，设计现在也可以。然后没关系，我们等一下有时间再来。那我先讲那个其他的，那个很好看，尤其是那个 design， 因为我们做 design 的，我就觉得其实都市设计也可以这样，让他自己去设计，让 AI 自己去设计。That's really amazing. Yeah. 对啊，好啊，因为我看到你们外面那个什么，不是，你们那个外面不是走廊有贴那个什么，你们是几周年纪念那个，然后你们有那个注解嘛，这是大的那个 urban planning 的这些大师哈，注解啊，有一个我看得很有趣啊，说先有生活才有空间才有建筑，我想the AI should do it in that way. This is the right sequence for AI to develop. Right, so this is a case. I think I chatted with faculty during the lunch time. This is the project that I collaborate with the Financial Information Agency 财资中心财税资料中心就是全国的这些财税啊什么所有的资料 raw data 在他们那边And we have a collaboration. What they are really interesting is how to we try to search some topic which couldn't be done before, but now we have supercomputer that we can do it. So then we think we can do some kind of money laundering. And they say, oh, this is a very exciting topic. Once we know who is doing money, even one single case, and this investment is worthwhile, okay? Because if you are doing these kind of calculations, maybe just if you do the full calculation of the budget to be spent for this kind of competition, it might be only a few millions. Okay, a few millions sounds big, right? But if you compare with billions, okay, money laundering can be billions, and that's really cheap. Okay, so we are talking about that, and I say, okay, I say we can do that, and so we try to develop some kind of we try to build some prototype for that. And so you can see here, this is a visualization, all the trading behaviors according to electronic invoices, 电子发票. So you can see the clustering, there's some clustering around. So this is around 3 million company, they are doing trading. And the data that we collected around 3 years data, okay? Not around it, precisely 3 years data. And they have some misdemeanor or criminal bear in mind. So there's a real case. So they like us to verify whether who is the wrongdoers. So what we do is visualize, and this is another high performance visualization technology as well. Try to clustering what's happening and visualize what might be crucial. And so what I really like to do is when we said money laundering, actually A sells to B, B sells to C, C sells to A. You have a single money laundry. 洗钱的话 ，A 洗给 B， B 洗给 A， 洗给 B， B 洗给 C， C 洗给 A， 这样子。可这个很好被抓，你这个叫3手啊。但是你如果抓7手的话，就会不见，真的会找不到。然后，所以他们如果抓到3手跟4手的话呢，他们就是要整个在租一个体育场，把所有的资料全部放在体育场里面，他们就是这样抓的。以前那个什么实信啊什么，就是这样抓的。我说 ，Well, maybe you can use this kind of technology to see what we can do. And guess what? So we actually has 3 million company trading for 3 years, and the total data is 400 million. 4亿笔的资料啊 ，400 million。没有，他一家公司，就是这边很多家公司。对，这是空间的，这是视觉化以后的，在空间视觉化。然后他用一种算法叫牛顿算法，就这彼此之间的交易比较频繁，他就把它连在一起。它当中你把这个线当成弹簧一样啊， 所以就说交易比较频繁，就是它的 weighting 比较重，它就会 cluster 在一起。但是，对，所以你就知道这边一定是通路嘛，通路跟谁都有嘛，但是通路不会作假，不是不会作假，就是说他要做这种大笔的洗钱比较少了。Okay, the story that I want to share is we're actually using 286 supercomputer big data Hadoop computers. 就是 big data 里面有个叫 Hadoop 的，对不对 ？Hadoop computing, and we're using 286 nodes, 286个节点超级电脑 ，and we calculate for 3 months, and the machine collapsed. So there's a complexity behind. We didn't understand it. You have to analyze the complexity of these kind of calculations. The complexity actually, there's a theory called small world, 小世界 Okay, so after 3 or 4 tradings, actually each node can reach every node. Okay, so how we tackle this kind of problem? We say, okay, just give us not 3 million to 3 million. We maybe pick up 20 or 50 or one single one to 3 million. Or 1对300万，300万对300万没有办法。我要里面看到他所有的1对1的这个 trading 的状况。我现在就一个，他现在给我们是50个，50个我们对50个对300万 ，that's solvable, but still take weeks to calculate it. Okay, so we conclude we actually closing these projects. Well, I don't think we claim it's a successful. I don't think it's successful. And during the pandemics, I was so panicked because I don't think this is success. This is a failure. So I'm thinking, trying to find some mathematical tools to help me and to find out what's happening. So later on, actually, I'm using a persistent homology. It's a topological kind of approach. I don't know whether you heard of it. It's very mathematics. 就是用那个拓扑的方式去算它们之间的那个就是它的那个 rank 是多少，然后来探讨出它可能的那个范围。So I can actually 3 million to 3 million, and I actually can filter around maybe 100 to 200. So you are narrowing down from 3 million to 200 to 100 to 200. So I think that's good enough. So and then I published in the financial journal, not engineering journal, and that's done. Okay, I'm not happy yet, but because I haven't further validated with the financial information agency. But this is one of the example of big data. Okay, and this is the one that I like to share because after to check around in the lunchtime with the faculty, I think this is the one that our center help. We actually built a GIS platform, okay, and it's a cloud platforms. And also, 就是我们跟国土规划，我们之间一直都有这个叫什么 national GIS， 是不是？有跟他们就是一直有在里面 involve 其中的 member， 然后他希望我们能够 take care. And there's an argument still in discussions because our center position is not serve government, but serve academia in general, serve research. We are doing kind of frontier research to kind of engineering or scientific innovations. So it's a different positioning, but still we try to help government as well whenever we could. And also by that, we develop some kind of platform for them. So this is the kind of cloud infrastructure they built, okay? 因为我发现每个公部门都在做自己的 GIS， 所以如果有设 cloud 的话就很方便。再来就是各个业务单位的资料也可以放在我们那里的话，那老师就可以非常 focus 在 research 就好了啊。这 ideally, but at least you can facilitate all the development for sure. Okay. Yeah, it's a good idea. Yeah. We can work together for that in the future. So this is the basic structure that we. So now you can see we like to provide. This is something that I mentioned. I like to mention, but we should check around. I forgot to mention again the digital twin. Okay, this is something that I think we should do it in particular for smart cities. whether you are doing simulations with the environment or your micro weather. This is something that I think is crucial. And of course, next step would make a decision and making the decision more efficient. We do support now, decision support, but in the future, maybe we can automate it and facilitate the decision process and make a decision more effective. And also, we talk about data governance, right? You have to improve the data governance for sure. And this is something that never done in academia. 所以资料治理在学术单位是没有这个观念的 100%. Even in our this institute like us, National Lab, we don't have the concept of data governance. We just try to kind of catch up this kind of concept a couple of years back, okay? But still, this is a very crucial issue. Actually, I have one slide. I just skip it anyway. I don't have too much time. Okay, so this is some of the examples, applications. This is kind of aligned with my topic, okay? And so in Academic Seneca, they have a noise map. So they put a lot of sensors around. This is a type of city. And so we help them to build a platform so they can demonstrate where the noise is in real time, okay? So this is one example. It's published already. Also, there's a system. This is the publications. All different kind of noises. Yeah, you can analyze it, the background noises, whether it's from where, but this is kind of general, kind of a 几分贝, this quantified, and to see what kind of noises, distributions. So you can, well, very similar, you can view this, what's the hotspot for COVID, there's one point, or hotspot of flooding, hotspot for what? Things that related to GIS. Yeah, this is another interesting example. So we didn't speak out, but you know what's happening. Okay. 这个大家知道了啊。我们有密切在注意，所以。Okay, this is another example. Actually, this is a kind of a digital twin on the flooding, and we try to. This is a kind of smart buildings. You can build a smart building or the sensors, so you have a digital twin in your virtual world. And so large digital twin will be a city, but I think city scale is a challenge, a future challenge for sure. And this is one example that we are coupling with a simulation of the, say, 这叫什么？浚沟了啊，就是水情监测了哈，抽水站的这个紧急监测，就是 flooding the mitigations, the processings, and this is actually the aerial images. So it is not just satellite imagings. So you can have a final resolutions and go down to more details, even more details with the aerial imagings. Okay, so you can go from say 40 meters to 10 meters pixels size, and then maybe go to 10 centimeters, 10公分的这个 accuracies. So there's a lot of possibility. If you go to these details, the data is huge. So including if you want a coupling with your simulation data. Okay, and this is a prototype, but I think this is the future should go. So there's another track of research which you're working on. If you have those kind of very big data, imaging big data, simulation big data, can we reduce the size and still visualize properly and be informative, the essential parts to the users. So this is the platform development that we are really focusing on. Another one is agriculture. Wow, digital twins. One is you have a dashboard. Dashboard is one thing. But if you want to communicate with the non-experts, say 立法委员, okay, they only understand this. So a graph means 1,000 words. It's really meaningful. You are doing, from my interpretation, you are communicate with the different domains people. If you look at the graph, actually different domains experts, they can on the same page. But if you using very specific equations or expressions, maybe a couple of people understand what you are doing, or maybe they are kind of impressed by your jargons. Okay, but anyway, so I think graph is always the things that you have to do. This is one thing. Second thing is, if you have a digital twin, you can do simulation. You can do predictions. So before it occurs, it's not just observing or monitoring. It's also something to do with the prediction. Something to do if then. For instance, if the rains go from 200 millimeters to 500 millimeters, what's happening in my city? You can do this hypothesis and do it in your twin, in the virtual world. You can't do it in the experimental world. And this was occurred in, say, aerodynamics, aerospace industries. They are doing these kind of things already for a long time. So you only do it in the virtual world. You do the sandbox in your virtual world. You don't do it in the physical world. For instance, the trustworthy collisions, okay? When the automobile industry, when they build a car, now 90% is built in the virtual world. They even do the crashworthiness, 就是做碰撞的那个在 in the virtual world. They don't do it in the real world. So only the last 10% when they pick up the right models, and only 2 of them when they do the real, because it's so expensive. So this is I think the digital twin is on some specific industry, but I think it will kind of spread to more industry because the costs are down now. There's a cost down for storage network, the one that I just mentioned. You can go to the cloud, and there's more kind of self-serving. You don't need to count now. You don't need to rely more on the experts now. You can do it yourself because the computer can do it. Computer play the role like an expert. Okay. 就好像你现在的相机或手机了哈。So you are dummy. It is smart. Okay. 你的手机 is smart, but you are dummy, right? You are dumb. Okay. Agriculture 就是你傻瓜，你的手机是聪明啊。好，那这个是农业上的应用，都一样啊。那另外一个是 underground, like for instance, the underground. I think this one will collaborate with the Tainan city, and 就是地下管线，我们都看不到，不知道怎么维护。所以你第一个是当然要 build up 起来，啊，然后它跟你的建筑物的 relationship 是什么？这个事实上地震都有资料的。And we actually has a prototype developed already, and we built those kind of underground pipe, and to allow them to kind of to investigate. And also, if you want to say excavate in order to do the road maintenance or your kind of pipe maintenance, you can use these kind of tools to realize whether this is the right place to dig in or not. Okay, so this is a kind of a GIS that we can use, also develop the platform that we can provide in our center. So the 3 infrastructures, whether it's a compute, network, or storage, are you able to sit in your office with a laptop, very low-end laptop, and to see what's happening, to visualize all the big data behind? The answer is yes now. So this is also the technology developed. It's still developing. Okay, it's not really general solutions, but it's more and more generalized now. Okay, and this is another one for land management. So the platforms help to visualize. And so this is collaborating with the Keelung city government. And we signed an MOU with them. And so we rebuild the entire, the local areas, all the buildings, and try to see what's the land use, including the vicinity of the areas. I don't know the details, but you are interested, I can forward you to, in particular faculties, I can forward you to my colleagues, okay, in the future. And now, of course, you can really enter in your digital twin and to see where you are. It's not very advanced at the moment, but it's there. It's usable, and I believe it will develop more and more. So you can see the Hollywood movie is now become a reality. Okay. 所以以前那个好莱坞电影演的那些科技啊，现在都可以，你可以戴着眼镜就走进去了啊。所以包括这个海底的啊，像那个我们的海盐号的那个实验船扫描那个海床的哈，那我们都把它重建起来啊。这个事实上都有影片啊，我现在是用 PDF， 实在太大，那个资料太大，大概500 mega。这个 underground pipeline, so the one that I just mentioned. Okay. This is pollution, air pollutions. This is with NCKU. PM 2.5. Okay. And this is traffic congestions. I'll give more details. And this is the one that we collaborate with MIT before, and the traffic system. And actually, initially, our collaboration, it's a long story, but anyway, initially, what's the United States, what's MIT really interested is if there's a more self-driving car on the road, what's the government policy should do? Okay, if there's a 20%, what's happening? You couldn't imagine it. You have to do simulations, right? What kind of tools that you can use? So what's MIT or Berkeley, they actually has a team, collaborative team. What they did actually using reinforcement learning and using Sumo. I don't know whether you heard of it. The Sumo simulators, it's a open source, SUMO, you can check it. And it's very, very sophisticated now. And these are very, very nice tools. And it's including 2D and 3D. And try to prove that if you have one single traffic car, a self-driving car, what's happening? So they do very fundamental research. For instance, 25 years ago, there's an experiment, very famous experiment. There's a Japanese professors, they do experiment for 20 cars around a big circle. They are driving on a circle in a constant speed, see what's happening. 就是20个汽车在一个大的一个圆环上面去开，然后没有任何红绿灯。你们猜会发生什么事情？然后每个驾驶人在驾驶啊，然后每一个都等速在开，你们觉得会发生什么事情？固定道路没有红绿灯，就是很大的实验场地啊，一个很大的圆环。这你们可以查得到，那个 YouTube 也有。Guess what's happening? Go sleep. 对。没有，它不因为很大的圈圈啊，但当然就是没有大到那种就是变曲线变直线那种，这还是弯的。我记得好像不到几分钟就 traffic jam， 非常短的时间 ，amazing。然后他们放了一个，if you put the self-driving car and the traffic becomes smoother. Because human being is not rational. 人是非常 irrational 的。不是打瞌睡，你可能这样看一下或怎么样，或者踩个刹车或什么的哈，对不对？或是稍微看一看，或是稍微加一点点油门哈。So every movement, every behavior, human behavior, there's an implication that it's irrational. That's a conclusion. Self-driving car is rational， 它是理性的，所以常常会发生。他们又一个 case， 警察是理性的，所以常常警察出现去控制那个当塞车的时候，警察会出现，他非常理性，他在判断，然后会指挥这边，对不对？所以他就是那个理性的因子，他就是那个 control factor。所以 self-driving car play as a role like a control factor. So it's the only single driving car, self-driving car. If you have a two self-driving car, what's happening? The simulation only following that. 他们 simulation 是这样，这 car 在这边，我只看前面的车，然后跟它保持等速。我的 rule 就只有这样的。然后经过这个计算之后 ，simulation 之后，你会发现 self-driving car 进去以后，整个交通变顺畅。所以你可以想象，整个城市如果是 self-driving car，OK， let's do it gradually. Okay, 10%, 20%, 50%. What's happening? 所以美国真的很厉害。They're really thinking ahead. If technology is there, what's the policy should follow in the future? They're really thinking ahead. Okay, this is what I learned. And so what we are helping is they're actually doing. There's no tools that are using observational data, which there's no tool that they can do the actual traffic. They can compare in a very small sections. But if you want to do, say, city scale, it's really not possible. So our proposal is we are actually using legacy CCTV and try to using artificial intelligence to reversely to calculate the velocity, the number of the car, the type of the car, the velocity of the car, even the acceleration of the car, and try to do it as accurate as possible and give a very large scale data. And we have been doing it for 3 to 4 years already. Right, so this is the things that we do. But we are thinking actually, whatever the data we can collect it, we can use it. Okay, this is the basic thinking, which means now you can consider whether it's a police kind of control the traffic, or you have a policeman, or you have a police car to control the traffic, or you have a traffic light to control the traffic, or whatever. And we call it the control factors. You introduce the control factor and to see what's happening. And sometimes very interesting, this block intersection will affect the other blocks. And this is something that we like to investigate further. If this project done, and this really can help policymakers to make a better decision, right? 所以这个部分的话，this is the recent research results. What we do is every intersections we actually put AI model, okay, LSTM, okay, long and short LSTM, long short-term memory, okay, it's a recurrent neural network. 它是用 LSTM 的方式在每一个路口 run 一个 model， 但我用的资料就是那边直接收集来的资料，我们可以 predict。那我忘记我同仁跟我讲的，大概是至少30分钟，对，30分钟。所以你只要查那个资料30分钟，这个很准。30分钟我可以 predict， 就是说30分钟后这边的 traffic 会怎么样。那这个就很有用，it's very useful already。所以我们这次跟台中市合作，那我们也提供给台中市。台中市政府也是非常 excited， 他觉得这个东西应该是蛮好用的 ，right？ 对。那这是我们系统的怎么做的哈？那我就跳过去。这是刚刚讲的它的 model LSTM。那这个 model 事实上是最早跟那个林大慧教授合作，能厕所。那边我们是做那个张斌离岸风能的那个 model， 我们不是单纯的 LSTM， 我们事实上是用 ensemble 的 model， 不同的 LSTM， 不同的 parameter， 然后选一个最好的，让他们ensemble 起来，然后这个我们把它用到交通小 case piece of cake okay, so these are comparisons, so we can predict the speed, predict the volume, sort of things, and also predict the trend. 这个还蛮准的，这个应该是比较的，就是我们跟那个实际的来做比较的。这个也是，这边有点不准，但是 trend 是一样的，这个是我们在那个台中科学园区最早跟他们合作，那我们就找了那个有一个四边形的一个 block， 井字形的 block， 然后我们现在是用 Sumo SUMAMO， 用 Sumo 在做 simulation， 把它 rebuild 起来。这个非常非常耗人力，虽然它是免费的软体但免费就是很贵的意思。那我们这个是用 quantum 的 algorithm 去做的，那这个另外一个是用 Fair MOT， 另外一个演算法可以做 real time， 非常 efficient， 比 ULO 4还好的一个软体你们可以 check 一下 Fair MOT 这是我们之前合作的。假设你的 traffic light 是根据你的交通 continuously 来 change control， which is not possible now in Taiwan, legally not possible。但是如果你可以做的话，是可以那个 improve speed 到 30%。然后 Q reduction 到 approximately 30%， it's a huge。我问过做交通的人，所以这个是非常非常大的 improvement。好，时间差不多了。好了，这是日本的 case 给大家看一下。所以现在 AI 用在什么地方你看这个是 CFD 的，都可以做了然后这边是做那个tsunami 的那个 flooding 的 prediction 他们也是这个是 assuming 的 flooding 这是 AI 的 prediction classic 的跟那个 AI 的。那这边的话是那个debris flow 叫什么？土石流土石流也是一样都是可以，现在都用 AI 来做。 好，这个是本来我后面很大一串的演讲啊，不过我想这个部分就稍微带过就好了啊。那我们常常在讲 AI 到底准不准啊什么的哈。那今年3月不是 ChatGPT 起来吗？大家吓一跳嘛，这个撼动全球啊。那个就是大家对 AI 完完全全是完全不一样的概念啊。所以大家又高娜把这个称为什么？就是就是说那种算是一个 breakthrough 的 AI 了啊。各位可以看到，你看这边是它的 model， 不同的 model 啊。那这边是 accuracy， 你们看发生什么事情？这边是它的参数的那个量，参数量10的18次方啊。参数你知道参数吗？哈，大家知道你们在做 AI， 简单 AI 是这样子哈，这边有几个 node， 这边有几个 node， 然后它 pass 过去，然后比如这边3个 node， 这边4个 node， 然后这个连接就3乘4，3是12个连接，对不对？那你如果画成那个 matrix 的话，就是什么？你可以是3乘4嘛，对不对？那个当然你也可以做12啊，但是在它里面就3乘4。那下一层这个4，譬如说4到2，你3乘4乘2啊，那个 neural network 没什么稀奇，就是这样的啊。那当然里面有些这个 engineering 的小技巧，3乘4乘2，所以你有一个 matrix 是3乘4，这个是4乘2，所以你就变成怎么样？矩阵的相乘而已嘛，对不对？好，你这样想就可以了。这样想来理解这个问题。那它的参数就什么样？这个矩阵就有3乘3、4、12个，因为12个连接嘛。12个参数，啊，那4乘2就有8个参数，所以这个3层的 network 我随便掰的哈，这个3个 network 就12加8有20个参数，好，那你们看看10的18次方，你可以想象吗？好，10的18次方 ，nothing happen， 10的24次方 ，nothing happen。我现在只问一句话，你如果是在做 computation 的话，你要不要放弃？我要毕业，老师我要毕业，对不对？啊，你说老师我做到10的22次方我要毕业，所以为什么是 OpenAI 做出来？不是学校里面没有任何人能做得出来，因为你们要毕业，没办法，老师要升等，所以你看什么事情在什么时候才发生？10的22次方以后才发生。发生多快？它是一个 jump. It's unbelievable. Only if they are big enough. 这个是没有任何人可以想到的。用 ChatGPT 写过程式的举手，少数吗？你们喜欢吗？满意吗？满意，很好。我也常用。我觉得我非常满意，啊，你看这边也是哈，所以基本上来讲，你看这个图几乎 no exception， 看你可以撑到多少，啊，那这个是上个礼拜吧，啊，那个联发科的那个技术总监呢，那我们在那个交大的产学技术与交流里面，他也讲到他们在 low level， 因为前面第一章讲 low level 的啊。这个是 Moore's Law， 就是刚刚提到的啊。那这个是 token per operation。So now they are talking about artificial intelligence process unit, AI unit called APU. So this is really you have to go down to the processing level instead of completely rely on GPU. So that's what's this is a very very hot topic in chip designer. They are doing this kind of development at the moment. But if you look at further. Neural network complexity, there's a jump here, a big jump. We are doing the AI, the one that I talk about, the money laundry, 那刚刚讲的，还有那个我刚刚提到那个 fish recognitions, recognized fish, facial recognitions, OK， 去辨别那个鱼。你知道鱼多难辨别吗？你知道鱼是不是？你知道鱼是2D 的动物，不是3D 的动物。鱼这样翻过来跟这样子看是不一样的，啊，我是做了以后才知道，我认为鱼是3D 的，鱼你任何看形状都不一样，而且我们做了以后才发生大麻烦，那个鱼小时候是男的，长大变女的，然后那个小时候很大，长大又变很小， 然后小时候会跟另外一个鱼呢，会假装成另外一只鱼，要保护自己嘛。哦，很麻烦。我们后来才发现选错题目。Okay, so this is the complexity. So you can see, so this is a kind of trend. Okay, if you want to do AI. So AI has two parts. One is training, which is you need supercomputer, the one large scale of the parameter that has to involved. Another one is the inferencing. 就是我现在拿来用 inferencing. Now you can install in your mobile phone, in your laptop. So this is another trend of the development. Right, so look at that. What's the AI development? AI, machine learning, and deep learning. So here, this is the models. This is only 2023. Okay, so we have a 100 trillion parameters already. 简单的讲是，你说老师，那我不要做研究这个，but you can leverage it. Okay. 你可以在这边来，你不是去做这个 training, okay? And another good news is that, okay, this is parameters. It's very interesting. John von Neumann, 现代电脑的创始人他说with 4 parameters, I can fit an elephant. 这是 elephant, 有没有看到 ？With 5, I can make him wiggle his trunk. 我可以让他的那个象牙wiggle 起来跳起来。Okay, so over-parameterized model are effective. 就是我们刚刚讲那个是 over-parameterized. 以前认为会 overfitting, 但现在 model 事实上就是在一个跷跷板上面。It's not as simple as it seems. 所以大家要注意到，这个就是我们从 big data move 到 AI 之后 ，big data, big parameters, and big parameters, big model, and big models, and general intelligence. So this is the current movement. And what we can do is not really investigate, but how to leverage it, how to take advantage of this kind of movement. So more models. So you can see here almost how many data you have, how good data you have. So almost your data means your models. 几乎就是这样子。好，你看到资料大概就可以知道你的 model。如果讲给老师听了。你们千万不要挫折。我跟你讲，因为我这样讲是因为我很挫折。有没有看到这个？这个快跟不上了。So, all right. So this is a kind of a even subsystem. They introduce a lot of stresses. So this is from economical perspective. Okay. So this is a kind of testing errors. This is simulations. This is a theory. Should go these directions, but this is actually parallel frontiers, which means the best, the optimal development will be in the future. All right, so can I stop here? 我等一下，我跟大家讲一下，我们后面有一个，这个也许我可以 share 给你们了。这我们同事有去开课了，全民参与了就是那个 large language 你们要的是不是做这个？你们要的是你们要的也不是这个，你们要的是这个。这个叫 prompt engineering， 这个是我觉得未来这是很新，今年才真的热起来这个 prompt engineering， 这个我觉得你们可以 catch up 其他的我觉得都是 jargon， 就是学的是对你没什么用，但是就是 make you excited， not that useful. But this is very useful.
OK， 好，谢谢方邦我想这个今天请这个林教授来大概很重要的工作就是我们今天做都市计划有很多不同的领域，对不对？那很多人讲说我要把它智慧化，要把它 AI 化，做很多的事情，但是你要有点 know how。今天我想方邦他给我们 demo 很多的例子这些例子都是实际上把一些想法从交通、从灾害很多都做到，所以我们系2馆的二楼那边有一个什么中心里面能够做几个这个东西，我想系上就有东西可以看了。那怎么做呢？第一个 data， first you need data, you need facility, computer they have, we need a software， 你们自己想办法去写。这3个连接起来就可以做这些事情了，看你的领域是什么东西。OK， So I think that's quite kind of inspiring. And do we have any question? We still have time for question from the audience. But we don't have question from the outstream, right? 没有办法从外面，但是我们现场可以有问题可以问，用中文问也可以哈。Any question？ 赶快跑！虽然林老师他不是我们都市，但是他做了很多东西跟我们的空间都市有相关哈。要，你就是
是，好，非常感谢林老师。用中文吗？还是英文都可以？好，中文好了。那我觉得今天的演讲对我非常大的启发，因为中午稍微聊一下我们最近在做这些 urban simulation 的事情。好，那我有几个问题想请教林老师啊，就是说，第一部分是 data management plan， 因为我们之前有一个整合型计划，跨了很多学校，不同的领域，有点像刚刚林老师的那些跨国计划，不同领域的人在做一个大计划。那这个 data， 因为它可能是 big data， 可能是即时的 data。那我们那时候其实总计划那边就希望我们做一个所谓的 DMP， 这样最近蛮流行，怎么去 management 这些 data。那后来其实做的我觉得哩哩啦啦，就因为大家的那个知识水准对，关于这方面的知识不太一样。plan， 对，就先有 plan 再去 management， 但没有人知道那个 plan 怎么生出来。那我比较想要请教林老师说这方面的经验，因为过去有非常多这种 data management 的工作。需要有专职人来做吗？还是说每一个 PI 都需要对这方面有一些了解，然后大家才能一起来合作这个事情？这可能是还是我先问第一个问题好了。
这个问题很核心啊。这个问题就是说，这张刚刚没讲。你觉得 data governance 跟 data management 有什么不一样？因为我牵涉到很多 eco 相关，我最早是做飞机设计，completely different field。然后，我们后来做全球的。那美国他们的想法是说，我必须要有一个 data， 所以你看到第一个就是说，为什么要一个 data management、data institute 在那里？因为 data 会有 life cycle， 这是第一个，你必须要有这个 recognition。第二个就是说，这种工作呢，不是一般 scientists involved 之后都觉得这是 trivial 的工作，然后大家都觉得很重要，但是都不能 publish 的，所以大家都觉得很重要的不重要啊，所以就是说，很重要又很 trivial 啊，所以通常他们就有大的计划，在美国他们就派一个人进来 manage。那我们自己是做 system 的，做 system 就会发现有一些东西是 scientist interested， 那我们做给他们，然后有一些东西是 management 需要的，我们也可能做给他们。可是他们两边之间的管道又不太一样，所以我后来 conclusion 就是说，我们必须要有一个 consortium， 一个 stakeholder， 能够 combine 这些 stakeholder， 就是说我们需要 consider another paradigm。后来我才发现，那个 paradigm 叫做 data governance。data governance 会 connect 到 who is responsible for data， 然后就是每一个的角色在里面，他是扮演什么，你必须要把它 define 住，否则老师跳进来，学生跳进来说，这个不是我的责任，这是你的啊，然后有一个跳进来说，这个是我就负责这一块啊，然后就是里面有很多在角色 overlap 跟模糊的时候呢，他认为这个不是我的，甚至于大家角色里面有一个角色没有被定义，然后大家都觉得彼此应该担任那个角色，所以 data governance 第一个就是 define 这个 proper roles 在整个 data management 的这个 plan 里面，但是就是说，或者是说 even higher degree， 就是说我今天包括做 strategy 的人，一直到 data 的这个 operation 的人service 的人， 他们必须要在这个 picture 里面。所以你可以看到，我后来发现这个才是很重要的一个解放。所以我们那时候就找了，当然现在有一些 tool 了啊，这是可以用。像我们之前是用那个 Cloud Pak for Data， 就是那个 IBM 的。那现在很多单位在用，你可以进去看一下他们的 concept 啊，叫 CP4D 啊 ，4 是1、2、3、4的 4，CP4D，CP4D 啊。所以你可以看到这边的这个 几个 key issue 啊，譬如说 quality 谁负责 ，data 收集到的时候会很清楚谁负责 ，data 开始用的时候会很不清楚谁负责，然后2个人在用的时候还可以知道，当3个人在用的时候就开始不知道谁要负责什么，然后最后就会推给某一个，那学生被 assign 就学生说老师这个跟我的 publication 没关啊，所以你知道 data preparation 是占你 research 的90%。Unfortunately， 你所有的 result 可能 rely on 那10%，可是你 data 为了要准备资料，而且资料还有生命周期，不要忘了。那你资料可能收集，结果发现漏了一段，你不能毕业，你怎么办？延毕，换题目，换老师。谢谢，我已经没力气了。他把它 po 在 Hugging Face 上面，然后呢，就是那个 Global 的那个 AI 的 model 的那个 GitHub， 然后呢，那个上面还用唐凤的名字，他们跟我讲说，唐凤名字在上面，这个是有的 ，data privacy 跟 data security， 就说这个会在你的 picture 里面。可是你一般在做资料的时候，你只做就是说我的 project 的 goal 我 achieve 就好。It's not right. If you look at the data, it's beyond your project scope. You have to introduce this. It's not data management plan. It's a framework. 对，你必须要就是架构在里面。That's the best I can suggest. 那我现在在我们中心里面也有推了，即使在推的话也是很困难。我现在要推就是说，研究人员 跟我学校好像也是这样，行政跟研究人员之间很多冲突嘛。那就是资料要不到啊，会要到资料，一天到晚跟要我一样的资料，然后资料改一点点又重要，然后我资料这边对不准，我的所有的预算资料跟 spending 跟那个什么都对不准，然后不同人数据又变了，所以每次 present 的 data 好像都不一样。我们主任也在问说，为什么每次 present 的 data 都不一样？他说 ，Can we help that？ 啊，而且那还是有专人在负责哦，完全 answer your question 了。It's not just single project。所以 framework 一定要，这我很确定。No, it's too big.
谢谢芳邦老师的那个演讲哈，那从里面学到很多，尤其是中午还有那个一个参叙在聊之后，那我发现谢谢彦仲老师，那里面有一个蛮有趣的部分，就是 AI 的发展，那当然很重要是取决于资料，那但是资料的建立的部分，资料建立部分，刚刚芳邦老师演讲里面也特别提到说，其实我们有很多资料准备，必须 for 某个 AI 的分析的方法，或者是那个方法需要的一个资料的格式，在资料准备上就可以往这方向走。那所以就让我联想到我们中午吃饭的时候，那个芳邦老师有提到说，现在中心这边预计要处理一个那个sensitive 那个 data 的 center 那这个部分就让我去思考一件事情，就是说我们现在好多不管是中午提到的一些公部门跟他要资料不容易取得，那这样的一个问题，那所以那刚好那个刚刚讲的 sensitive data center 也正在准备要扮演这个角色。那所以在这个角色上，不管是刚刚提到的，或是中午我们聚餐的时候大家在聊的，那在这一个敏感资料中心有没有什么样一个 propose 的一些方向或是架构？那可以把我们刚刚中午吃饭的时候提到的，其实那个属于那个财税方面的资料，或者是属于那个卫生方面的资料，那甚至水资源、电力等等资料，是有一些 proposal 架构。那甚至我们系上的老师们或者是同学的研究们，有机会在这个 proposal 架构里面扮演一些角色，可以帮忙做一些提案有没有这样的一个可能性跟这个资料的架构能够搭在一起的？
我们都希望朝那个方向 ，ideally yes， 但是我们现在在想的就是可能就是project based 方式，然后 data governance 就是我们把 stakeholder 找进来，然后 infra 就是我们那边可以整个 facilitate 整个 research 的 development。那如果你把 stakeholder involved 之后呢，资料的取得在 project wise 的 contract 里面呢比较容易实施。问题是在计划结束后的资料，未来要使用的时候。这个部分的话，可能要再讨论。但是第一个可行的，我们可以先这样子来做。然后我今天中午跟你们聊我的心得，我也学到很多。那我的心得是，这边的需求，也许我们在发展当中，我们可以 incorporate 到，就是说，真的在学界有这个需求，然后这个需求事实上可以 help government，就是这是两边的，就是的这个。整个的 decision making 或是 policy making 这相关的，绝对可以improve the quality of the policy for sure。那我们基本上就是，如果可以 manifest 这种东西的话，那这个慢慢的这个资料中心、敏感资料中心呢，就可以 grow。对啊。那另外一个议题就是说，应该是这样讲，就是说，目前在台湾真的可以 qualified private 的不看。的这个这种facility 的中心，大概就我们的单位，大概就我们，没有别的。所以数位部也找我们，好多都找我们。对，那我就跟我们主任讲说，那我们的定位就错掉了。我们应该自行成立一个行政法人。这是另外一个这是 total solution。 可以讲说如何减重。No, not secret. It's not confidential at all. 没有，就是跟大家讲，就是同学现在没有语重心长，这个很重要啊。就分享我的心得，就是熬夜跟大家保证，对你的工作啊各方，除非当然要赶东西了哈，熬夜对你没有帮助，对你的思考也没有帮助，真的。最好的思考真的是早上起来，所以同学最好睡7个小时。啊，当然我是为了，因为我心脏有点问题啊，所以第一个睡眠，因为我小孩现在在工作，我小孩就是这样，我知道啊，其实大部分都是 distracted 啊，去干 game 啊，或者是玩 game， 或者是会新闻什么会被 distracted， 所以你如果仔细的去那个计算你自己的使用时间，每天的使用时间哦，你会发现你还不如把它用在你的睡眠，这是第一个。第二个呢，也是我语重心长的。大家不会像我这样为了减重哇拼命的走路啊，走1个小时2个小时，但你走个15分钟，吃饱饭走一走，这是第二个我觉得非常重要。第三个呢，就是大家很喜欢吃哇这甜点吃那个，不是说不能吃，就是说大家一定要营养均衡。所以呢，听起来都是平凡无奇、老生常谈，但你只要每天做得到，你就是一辈子的 impact。也不用每天做得到，你只要2-3天呢 regular 的做得到，那就有非常好的 impact。这是我现身说法啊。
谢谢哈，我现在每天走1万步已经走了800多天了，啊，800多天你们算一下几年了哈，而且是每天都有达到目标啊。好，那个芳邦他给我最大的一个启发是，他碰到的事情都非常的 open mind。不是一开始就把它先拒绝掉，而是你在不同的领域里面你碰到他就有兴趣试试看，然后慢慢试了就会试出一个东西出来。好，然后再加上任何东西你不是只有讲概念，我特别要强调，都市计划不是只有概念，一定要有 know how。那这就是一个技术，好好的把这些今天的这个心得应用在你自己的研究领域，好好去思考一下。如果是你们的话，我自己会写一个我自己的 note， 我的研究领域是什么东西，兴趣是什么东西。然后我今天学到什么样的技术，要把它应用在我的研究，我会碰到什么样的问题，写下来。Okay, for PhD students, you have to file out a report next week, right? So try to think about what is your research interested and the data, what you should collect it, okay? And know how that's also important. 我们再次谢谢林芳邦林老师。OK， 好，请客没问题哈，没问题。好吧，那你们有话要跟同学讲吗？
硕班同学，那个我们再次热烈掌声感谢林教授，谢谢。那个我们下礼拜就回复到继续那个导读跟报告。那关于我跟永琪老师的那个导句我们大概找了2间店啊，一间呢是喝到饱的，一间呢是很好吃的，但是时间上现在还在瞧看哪一间在我们现在选的时间是11月17号，就礼拜五，我们大家那个硕班专讨结束之后就可以去吃喝。好，原则上我跟永琪老师的导生，请你们尽量务必参加。然后伟如老师的导生，因为我们的那个导句就是硕1、硕2啦。好，那伟如老师这边的导生呢，欢迎参加。好，这样就懂了哈。就是说，老师这边的导生是和永琪老师这边的导生，因为没有再额外一组一组的去吃导句啦，所以是请你们务必尽量这个务必参加。那伟如老师这边的导生呢，因为我们知道你们已经跟伟如老师开始在吃了，所以想要来一起玩的就欢迎参加。好，大概是这样子。那我是不是请那个就是陈忠这边帮忙统计一下11月17号，好，我们会是包场的一个状况。然后11月17号 晚上应该是6点左右会开始哈。那10月17号能来的，务必要跟陈宗这边稍微登记一下，好，他可能在做表单什么之类的。好，那不就说你应该这样讲，你真的不能来，好，就不要硬盯，没有关系。那老师会再另外找别的方式来关心你，好不好？好，那就请那个，因为时间上面我们想要不要太靠近期末，然后又要避开大家那个期中考啊，干嘛的，所以呢，就定在11月17号。好，那17号晚上，如果你真的没有办法来的话，好，那个我们反正到时候人数上面我们统计一下，会跟餐厅讲。真的没有办法来，我们再找时间，好，再另外再用别的方式关心各位。好，同学有没有问题？没有哈，没有的话，那就这礼拜我们就到这边，谢谢大家，下礼拜我们再继续，谢谢。